In this lecture, we'll cover basics of junction transistor, the very basics of the transistors. Transistors are semiconductor devices which are made of combination of Pnp, or I can say Npn. There are three layers. One is called emitter, another is called base, and third one is called collector. There are certain basic characters of this. Emitter is heavily doped, but moderate in size. Collector is large in size. In fact, it collects most of the majority carriers which come from emitter. We'll take up that. That is why the size is large and doping is moderate. And base is sandwiched between emitter and collector. It is thin and lightly doped. This is the basics of emitter, base, and collector. Let us take Pnp transistor, where emitter is P type, base is N type, and collector is again P type. We can take Npn also, but I am right now taking Pnp. First of all, we should know how to draw the symbol. When you put it in a circuit, what symbols signify the transistor? The symbols are this. This one is taken as emitter, this is base, and this is collector. If it is Pnp, this is P type, this is N type, this is P type. An arrow has to be marked between base and emitter. Arrow has to be marked, and arrow will always be marked from P type to N type. Remember, arrow is marked always from P type to N type. So this is the symbol for Pnp transistor. Suppose it is Npn. P and N. This is N-type semiconductor, N-type semiconductor, base is P-type. Again, there has to be an arrow mark between base and emitter, and arrow is always from P side towards N side. So for Npn transistor, this is the symbol, and for Pnp, it will be reverse. Pnp, it will be just the reverse. It will be P, it will be N, and if it is P. So this is how the symbol is marked. Now, how the transistor operates. Let us redraw this again. This is a junction transistor with three layers. Each boundary, this is P, this is N, this is P. This is the junction boundary. So there will be a depletion region here and also a depletion region here at the junction boundary. P side has what is the majority carrier? The majority carriers in P side are holes. Here the majority carriers are electron, but they are less in number because it is lightly doped. They are very large in number because it is heavily doped. Again, the majority carriers are H here, not as large as emitter, but still large. So holes are majority carriers, electrons are majority carriers. When we operate this transistor, we apply forward bias between emitter and base. It is a common base configuration. Base is common, you can see in the circuit. We apply forward bias to emitter base junction. Forward bias always means P positive, N negative, to remember it. And this is the forward bias. Whenever there is a forward bias, there is a current because of majority carriers. Please remember, in forward bias, majority carriers lead to current. In reverse bias, minority carriers. This is basic of semiconductors. Now forward bias we apply here, and here we apply reverse bias. And I will tell you why it is reverse bias here. We will apply reverse bias. Reverse bias means P will be connected to negative. This is positive like this. Positive, negative, positive, negative. This is reverse biased and this is forward biased. Positive to P, negative to N. Here it is positive to N, negative to P. This junction will be reverse biased. This is forward biased. When this is forward bias, the holes, as I said, in forward bias, it is the holes which create the forward bias. It is the majority carriers. So majority carriers will cross over from P side to N side. And interestingly, these holes which are majority here are now minority carriers here. Are minority carriers. Holes are minority carriers in N type. They are minority. As it is thinly doped, these holes which are crossing over do not recombine with all the electrons, means these are not neutralized, but they swamp the electrons, means they are in very large number. These majority carriers here are in less number. So the majority carriers which are crossing over here, though they are in minority here, holes means N side means holes minority and electrons majority. Small m from minority. P side means holes are majority and electrons are minority. This is basic, we should keep in mind. So holes are effectively minority carriers here, and they are, since it is very thinly, this is very thin layer, so these electrons are near this junction boundary, and this is now reverse biased. In reverse bias, the minority carriers carry the current. Holes are minority carrier here, though they are in large number. Since it is N type, they are minority carriers. Since it is positive and holes are here, they now cross over to P side from N side, where they are the majority carriers and they are collected. So it is whenever the minority carriers cross when there is a reverse bias, and majority carrier cross when there is a forward bias. So you see, if I is the emitter current and IC is the collector current and IB is the base current, IE is equal to IB plus IC. IB is very small. In fact, IE can be approximated as equal to IC. So most of the current from emitter crosses to the collector. So this is the basic working of Pnp junction transistor. If it is Npn, Suppose now we take the Npn junction transistor. The biasing will have to be different. Now take Npn. This is emitter, this is base, this is collector. This is N, this is P, this is N. Electrons are majority carriers here. Holes are majority carriers here, but less in number because it is thin and lightly doped. It is moderate in size but heavily doped. And again, electrons are majority carriers here. It is moderately doped but large in size. We apply forward bias between emitter and base. Forward bias means this time N has to be connected to negative. This is forward bias, and we apply reverse bias to base collector junction. Reverse bias means N has to be connected to positive. Positive, negative, positive, negative. Negative, positive, negative, positive. Positive is connected to N. When positive is connected to N and negative to P, it is reverse bias. When negative to N, positive to P, it is forward bias. Now, because of the forward bias here, it is negative. Electrons are majority carriers. In forward bias, as I said, it is the majority carriers which cross the junction. Electrons will cross the junction and they swamp the holes which are majority carrier here. Holes are majority in P, but they are less in number because it is lightly doped. So most of the electrons, they find themselves closer to the junction boundary, and here it a reverse bias. Electrons which were majority here are minority in P side, minority carriers, and the reverse bias current is because of the minority carriers, so the electrons easily cross over to the collector. So this is I. The flow of current will be like this, IE like this. This is IC, and the electrons are crossing like this. So this is IB. So again you will have same relationship. IE is equal to IB plus IC for NPN also. IB is very small. We can take IE approximately equal to IC. So by applying the appropriate reverse bias and forward bias, we can control the flow of current, and that is how electronic devices are operated, by using proper biasing. We will deal with that in subsequent lecture on how transistor. We will take there a case of a common emitter transistor, how it can be used as amplifier and it can be used as switch. This was just the basic of what is forward bias, what is reverse bias in a transistor, what is emitter, what is base, what is collector, and the symbols of the transistor. How do you show the arrow? What do you mean by forward bias? What is the current which dominates in forward bias? It is the majority carrier current, and in the reverse bias it is minority carrier current. The majority carriers in one side can become minority carriers on the other side when they cross the junction boundary. So that is all on the basics of junction transistor. Thank you.